Imagine you're an astronaut exploring the vast expanse of space. You reach for your trusty torch, but would it ignite in the cold vacuum? Could a fire burn without gravity, a force so fundamental to our experience on Earth? The answer, like the universe itself, is surprisingly intriguing. Fire, at its core, is a chemical reaction. It doesn't need gravity to exist. But gravity does influence how it behaves, shaping the familiar flames we see on Earth. To understand fire's behavior in space, we must first understand the fundamental ingredients that fuel its existence. It turns out, fire has a few essential needs. Just like humans need air to breathe, fire needs oxygen to survive. But oxygen alone isn't enough. Fire also needs fuel, something to burn, like wood or propane. And finally, it needs heat, a spark to initiate the fiery dance of combustion. Fuel, oxygen, and heat. We call these three essential ingredients the fire triangle. Oxygen, fuel, and heat must all be present for a fire to start. Remove any one of these elements and the fire is extinguished, just like blowing out a candle disrupts the flow of oxygen. But gravity plays a crucial role in how this fiery triangle interacts. On Earth, gravity pulls cooler, denser air downwards, creating an upward flow of air around a flame. This is why flames on Earth typically point upwards, like a sunflower reaching for the sun. This upward flow of air does two important things. First, it delivers a constant supply of fresh oxygen to the flame, keeping it burning bright. Second, it carries away the byproducts of combustion, like smoke and gases, preventing them from suffocating the fire. Flames rise because hot gases are less dense than the surrounding air, making them buoyant. This continuous flow creates the familiar upward shape of flames on Earth. Gravity pulls denser, cooler air downward, which pushes the lighter, hot gases upward. Hot air is less dense than cold air, so it rises. This is why hot air balloons float. In a fire, the hot gases produced by combustion rise, creating an upward draft. This upward draft, combined with the influx of cooler air from the sides, gives flames on Earth their characteristic teardrop shape. But in the microgravity environment of space, this upward flow doesn't occur. Hot gases do not rise without gravity-driven convection. So flames burn in a small, spherical shape instead of the familiar teardrop form. Without gravity to dictate the movement of hot and cold air, flames behave quite differently. Experiments conducted on space stations have revealed fascinating insights into fire's behavior without gravity's influence. These experiments showed that flames in microgravity spread more slowly, burn cooler, and exhibit cool flames at lower temperatures. Solid fuels burn more evenly without gravity's influence, and combustion is often more efficient and cleaner, resulting in a dimmer, more long-lasting burn. In microgravity, flames burn in a sphere, expanding outwards in all directions. This is because there's no upward pull to elongate the flame. After all, they lack the constant influx of oxygen provided by gravity's pull. Understanding how fire behaves in space is crucial for the safety of future astronauts and the success of long-duration space missions. It informs the design of spacecraft fire safety systems and helps us understand the potential risks of fire during space travel. As we venture further into the cosmos, unraveling the mysteries of fire in space will continue to be a burning pursuit. If you enjoyed this cosmic journey, don't forget to hit that like button and subscribe for more astronomical wonders.